Now, like trig, we have the inverse hyperbolic functions. So we have rsin, rcos, and rthan. If we were in normal trig, we'd have arc sine, but for hyperbolics we drop the c, so we just get rsin. Well, this I guess you could also say inverse sine, inverse cos. I find this easy to say, but whatever your preference is. So, just like we've defined the hyperbolics to be like this, the inverse hyperbolics are defined to be like this. And it's asked in the exam for you to prove it, like y is r sine of x, ln of x plus square root of x squared plus 1. Well, it's kind of like, I think it's similar to actually in normal trig when you're proving the derivative for arc sine and arc cos x, where you have to do the like 1 over square root of x squared minus 1, I think. So it's similar to that. So we want to prove that r sine of x is equal to this. Well, first let y equals r sine x. Well, this gives us that if we take sine of both sides, we're going to get sine of y is equal to x. Well, sine of y we know is just e to the y minus e to the minus y over 2, and this is equal to x. So what we get is multiplying both sides by 2, we get e to the y minus e to the minus y is equal to 2x. Because we've got this e to the minus y over here, we'll multiply both sides by e to the y, so we get e to the 2y minus 1 is equal to 2x e to the y. Now we can kind of get like a quadratic from this, so if we get e to the 2y, we'll minus 2x e to the y from both sides, so we'll get minus 2x e to the y minus 1 equals 0. And here, instead of, you could use the quadratic formula, but it would just be easier in this case to complete the square. So we get e to the y, and then half the b term, so minus x. Square that, we're going to minus x squared, and then we've got the minus 1 at the end equals 0. So we're going to get that e to the y minus x all squared is equal to x squared plus 1. Well, we're going to square root this now, so we'll get e to the y minus x is equal to the plus minus square root of x squared plus 1. Now we're just going to add x to both sides, so we get e to the y is equal to x plus minus square root of x squared plus 1. We've got e to the y, we just want y, so y is equal to ln of x plus minus square root of x squared plus 1. Well, actually it's not really going to be, because we've got a logarithm, we know that we cannot take the log of a negative number. And, well, this square root of x squared plus 1 is going to be greater than x, because we know that the square root of x squared is just x. So, therefore, the square root of x squared plus 1 is greater than x. So what we'd get is, if we had x minus the square root of x squared plus 1, well, we're going to get x minus something that's greater than x, so the whole thing is going to be negative, and we'll be taking ln of a negative number, so it's not ln of x minus square root x squared plus 1, as we number. Therefore, y is equal to ln of x plus the square root of x squared plus 1. And we said earlier y was r sine of x, so this is just equal to r sine of x. And we have proved it, ln of x plus square root of x squared plus 1. Oops, I will just move that all up here. Now let's do the same for arc cos. So, first let's let y equal minus 1. But again, with this plus minus, we have a problem with this. Now, if we go back to here, because we're doing with arc cos, we're going to look at cos. Now, just like in normal trig, when we got like cos and arc cos, all we did was reflect the cos graph in the line y equals x. So we're just going to reflect it in the line y equals x. So this would map to like here, this would map to like here, this would map to like here, this would map to like here. So we're getting something like this. So the shape is going to be something like this. But look what happens. If we have an input of 3, well, the output is this, but also this. If you have an input of 4, it's this, but also this. We're getting like 2 solutions just for one input, which isn't possible because a function is a one-to-one or many-to-one thing. It cannot be one-to-many. A function cannot be one-to-many because one input will only give one output. You can have many-to-one, which is like here. Like here, if we had x as 1, it would only give us one output, which is up here. If x was 3, it would give us something up here. If x was minus 2, it would only give us something up here. We are getting a one-to-one or a many-to-one because here that's when x is minus 2, and here the same place x is like somewhere here. So we're getting many-to-one, but a function can never be one-to-many. So having something like this gives a one-to-many like input-output thing. We're getting like 2 solutions for one input, which isn't what a function is. So that breaks the meaning of a function. So what it is the arc cosh x graph. It can't be like this because that's when we're getting the one-to-many function. So if we just disregard this, the arc cosh x graph is just going to be something like this. So here it's positive, therefore this has to be positive. So it's not going to be ln of x minus the square root of x squared minus 1, as r cosh x is positive. Therefore we get y is equal to ln of x added to the square root of x squared minus 1, and we said earlier y is arc cosh x, so this is arc cosh x. Proved. Now this one, r than x. Well, r than x, first let's let y equal r than x. So we're going to get x is equal to than of y. So we're going to get x is equal to e to the 2y minus 1 over e to the 2y plus 1. So we're going to multiply by the denominator, so we're going to get x e to the 2y plus x is equal to e to the 2y minus 1. Well, now we're going to factor out e to the 2y from both sides, so let's just move e to the 2y and x to different sides. So we're going to get x e to the 2y minus e to the 2y is equal to minus x minus 1. Well, minus x minus 1 is just minus x plus 1. We're going to factor out e to the 2y, so what we're going to get is e to the 2y into, and this will just leave x minus 1. So x minus 1, and that was equal to minus x plus 1. Well, now we're just going to divide by x minus 1, so what we're going to get is e to the 2y is equal to minus x plus 1 over x minus 1. Now we can just distribute this minus over here, so we're going to get, instead of x minus 1, we'll get 1 minus x, so we're going to get x plus 1 over 1 minus x. And I guess just rearrange this, so instead of x plus 1 we get 1 plus x because we want to make it look like this. Well, now we've got e to the 2y is equal to this, so we can take ln of both sides and get 2y is equal to ln of 1 plus x over 1 minus x. Now just times by half, we're going to get y is equal to half ln of 1 plus x over 1 minus x. And we said y is r than x. And the modulus of x must be less than 1 because, well, x has to be less than 1 but above 0 for. So yeah, so this is the introduction to hyperbolic functions. We've got the graphs of each and like the definitions of each, and then we've got the inverses. So these proofs you basically have to know because they have come up as questions before and you're expected to know these. But step by step, like this has been an exam question before, I've done this. As long as it's in your head and you understand what you're doing, you'll be fine. So I hope this was helpful. Next we'll be going on to hyperbolic trig identities. Goodbye.